For number 1 on the Chapter 3 review sheet, we want to get f of x to look like one of the choices in the multiple choice. So if we look at 1/8 and 4, we want to think which base can we change both of those numbers to so it will look like one of our choices. So it looks like I can either change them to have a base of 1/2 or a base of 2. And since 1/8 is a fraction, I am just going to rewrite that as 1/8 to the 3rd power. And then to rewrite 4 with a base of 1/2, that would be to the negative 2nd power. And then I still have to the 2 minus x. So if I have two exponents that are being multiplied, or I'm sorry, one exponent being raised to another exponent, I can multiply them. So I'll have 1/2 to the negative 4 plus 2x. And since I have the same base, I can add my exponents together. So I'll have 1/2 to the negative 1 plus 2x, and that would be choice A. For number 2, we want to rewrite the logarithms in exponential form. So the base of the logarithm is going to become the base of the exponent. So this little 5 is going to rotate around and become the base, and 12 is going to become the exponent. So the log will go away, and we'll have z equals 5 to the 12th. For part B, you can't see it, but there's actually a base of e for a natural log. So the e is going to rotate over, and the 3 is going to move up, so we have x equals e to the 3rd power. For part C, the b will rotate, and the 3 will rotate up, so 8 will equal b to the 3rd power. And for D, we have an e, and the e will rotate, the x will rotate up, so 16 will equal e to the x. For number 3, we want to do the opposite and take something in exponential form and rewrite it as a logarithm. So the base of my exponent is going to become the base of my logarithm. So log base 5 of 125 will equal the exponent 3. And log base x of 32 will equal 5. And log base 25 of x will equal 3/2. And log base 12 of 1/12 will equal x. For number 4, we want to evaluate the logarithms without a calculator. So when we evaluate a logarithm, we always want to ask ourselves, for example, in part A, 8 to the what power equals 8? And that answer would be 1. For part B, 4 to the what power would equal 2? And since we would have to square root a 4 to get a 2, that would be 1/2, since raising something to the 1/2 is the same as square rooting. For part C, we have 25 to the what power would equal 1, and anything to the 0 power equals 1, so that would equal 0. Here we have 5 to the what power would equal 1 over 125, and since we need to create a fraction, we're going to have to raise it to a negative exponent, and it would be negative 3 since 5 cubed is 125. For E, the log base 6 of 6 to the 3rd is kind of like asking yourself 6 to the what power would equal 6 to the 3rd, so it would equal 3. For F, we have 8 to the what power would equal 32. And this one's a little bit tricky because we can't raise 8 to anything to get 32, but we can raise 2 to the 5th and get 32. So to make 8 become a 2, we have to take 8 and raise it to the 1/3. That would make a 2. And then we have to raise that to the 5th power to make a 32. So this would really be to the 5/3. For g, whenever you have a natural log and an e right next to each other, they would cancel out. So this would just equal x squared plus 5. And for h, if you don't see a base, it really has a base of 10. So 10 to the what power would equal 100,000. And since it's 5 zeros, it would be to the 5th power. For number 5, we want to condense the logarithm to help us answer the question. So we want to know what is log base 4 of 8 plus log base 4 of 16. So that would be the same as log base 4 of 8 times 16, since addition condenses into multiplication, minus log base 4 of 2. So whenever you have subtraction, that condenses into division. So we really want to know what is log base 4 of 8 times 8, which is the same as log base 4 of 64. So then we want to ask ourselves 4 to the what power equals 64, and that would be to the 3rd power. So the answer is 3. For number 6, we want to find the value of 2 times the natural log of e to the 8th without using a calculator. So whenever we have a natural log and an e right next to each other, they cancel out. So basically we just have 2 times 8, which would equal 16. For number 7, we want to use the change of base formula to rewrite log base 4 of 23 as a common logarithm and as a natural logarithm. So this is how you would want to put this in your calculator to calculate log base 4 of 23. So we do the log of 23 divided by the log of 4. Or you would get the same answer if you typed in the natural log of 23 divided by the natural log of 4 into your calculator. For number 8, we have log base 3 of x over the 6th root of y, and we want to expand that so it's a sum of difference of multiple logarithms. So first we want to expand using subtraction, since we have 2 terms that are being divided by each other. So that would be log base 3 of x minus log base 3 of the 6th root of y. And whenever we take a 6th root of something, it would be the same as raising it to the 1/6. So now that 1/6 is an exponent, we can bring it out to the front of that term. So our final answer will be log base 3 of x minus 1/6 log base 3 of y. For part B, we see that we have 3 terms on the top and 1 term on the bottom, so we should have a total of 4 logarithms when we expand it. So first we're going to expand all of the terms on the top of our fraction with an addition sign. So we have log base A of 2 plus log base A of x cubed plus log base A, and I'm going to change that square root of y to a y to the 1/2, minus log base A of z to the 5th. And then the very last step is to take all of our exponents and move them to the front. So we have log base A of 2 plus 3 log base A of x plus 1/2 log base A of y minus 5 log base A of z. In number 9, we want to condense the logarithm. So first thing we're going to do is take all of the coefficients and move them to the exponent of their term. So we're going to have log base 4 of x plus 4 squared, and that will be minus log base 4 of x plus 6 cubed, and then we still have the plus 1/2. Oh, sorry, the 1/2 is going to move. Let's take that 1/2 move it. So we'll have log base 4 of, I'm just going to write it as the square root of x, because raising x to the 1/2 is the same as square rooting it. And now we're ready to condense our logarithm from 3 logarithms to just 1. So I'm going to have 1 log base 4, and x plus 4 squared and the square root of x are both positive, so they're going to go into the numerator of my fraction. And I'm not going to distribute the squared, I'm just going to leave it as x plus 4 squared and the square root of x. We don't have to simplify any further. And then since we are subtracting x plus 6 cubed, x plus 6 cubed is going to go in the denominator. And then for number 10, we want to condense the logarithm and select which answer it matches with. So again, I'm going to take all of the coefficients and move them to the exponents. So I have log base 7 of x to the 4th plus log base 7 of x minus 6 cubed. And then those will get condensed by multiplication since we have addition. So we'll have log base 7 of x to the 4th times x minus 6 cubed, and that is choice C. For number 11, we want to solve the following logarithms for x and check for extraneous solutions. So for part A, we first want to write it in exponential form by taking the 3 and rotating it around. So we have x minus 1 equals 3 squared. So x minus 1 equals 9. So x will equal 10. For B, the log base 2 and the 2 will just cancel. So we're just left with x plus 3. And we can just leave the answer like that since it's not equal to anything and we're not really solving for x for B or C. And then for C, the 4 and the log base 4 will cancel. So this will just equal 64. For D, we cannot solve an equation if we have 2 logarithms on one side. So the first thing we need to do is condense. So I'm going to condense using multiplication. So I have log of x times x minus 9 equals 1. And then this log really has a base of 10 that I can't see. So I'm going to take the 10 and rotate it around. And I'm going to multiply through the x. So I'm going to have x squared minus 9x equals 10 to the first. And then I'm going to get everybody on one side so I can factor and solve. So I have x squared minus 9x minus 10 equals 0. So that will factor into x minus 10 and x plus 1. And so I'll get 2 answers, x equals 10 and x equals negative 1. And the only answer that I want to keep is x equals 10. X equals negative 1 is extraneous because if I plugged it back in, we cannot take logs of negative numbers. So x equals 10 is the only one that works. For part E, I have 2 logs on one side with log base 6 of 12 minus log base 6 of 3. So I'm going to condense that side first using division. So I'll have 12 divided by 3. And so now that I have 1 log on each side, those logs can cancel out. So I'll have 2x minus 3 equals 4. So 2x will equal 7. So x equals 7 halves. For F, again, we're going to condense. So we're going to have log base 3 of x minus 2 times x minus 4 equals 2. And then we are going to rotate the 3 around and get rid of the log and FOIL out our x minus 2 and x minus 4. So I'll have x squared minus 4x minus 2x, so minus 6x plus 8 equals 3 squared. And then I'm going to move that 3 squared, which is 9, to the other side. So I have x squared minus 6x minus 9, so minus 1. equals 0. Now, unfortunately, that is not factorable. So I'm either going to have to use the quadratic formula or complete the square to solve. So I think completing the square on this one might be a little bit of an easier way to go. So I'm going to first take my 1 and move it to the other side. And then I want to divide by 2 and square it, so I'm going to add in a 9. And then factor, so I have x minus 3 squared equals 10. So x minus 3 will equal plus or minus the square root of 10, and then I'm going to add 3 to the other side. So x will equal 3 plus or minus root 10. And I only want a number that is bigger than 4, or else if I plug it back in, I'll get extraneous solutions. So x equals 3 plus root 10 will be the only solution that works. For g, I have 2 times log base 3 of x equals 3 times log base 3 of 4. So first I want to take my exponents and move them, or I'm sorry, my coefficients, and move them to the exponents. And since I have 1 log on each side, they can cancel. So x squared equals 4 cubed, which is 64. So x will equal plus or minus 8. But I only want the positive version. So when I plug it back in, I won't have any undefined answers. So x equals 8. For h, we want to first condense on both sides. So I'm going to have the natural log of x plus 6 divided by 10 equals the natural log of x minus 1 divided by 2. And since I have a natural log on both sides, they can cancel out. So x plus 6 over 10 equals x minus 1 over 2. And now I can just cross multiply and solve for x. So x plus 6 times 2 will be 2x plus 12, and x minus 1 times 10 will be 10x minus 10. And I am going to subtract 2x and add 10. So 22 will equal 8x, and then when I divide by 8 and simplify, I will get that 11/4 equal x. And 11/4, if we plug it back in, it's a good answer. For I want to first see if I can get the bases to be the same. So I know that I can change 27 to have a base of 3, because it is 3 to the third. And now that the bases are the same, I can just multiply the exponents. And then I can just take my exponents and set them equal to each other. So 10 will equal 5x, so 2 will equal x. For part J, we can factor e to the 2x plus 2e to the x minus 15. And we want to think about factoring that similar to the way that we would factor x squared plus 2x minus 15. And we'd factor that like x plus 5, x minus 3. So to factor j, we're going to factor with an e to the x plus 5 times an e to the x minus 3, and then take both of those factors and set it equal to 0. So e to the x plus 5 equals 0, and e to the x minus 3 equals 0. So e to the x will equal a negative 5, or e to the x will equal 3. And then to get rid of e, we want to natural log both sides. So x will equal the natural log of negative 5, which is undefined because we can't take the natural log of negative. So we'll only have one answer, and that is x equals the natural log of 3. And for k, our logarithms just cancel out because we have one log on each side. So we'll just have that x squared equals 6 minus x. And then we'll move everybody over to one side and factor. And then we'll get that x equals negative 3 and x equals 2. And if we check, both of these solutions actually work when we plug it back in. Because if we plug in a negative 3 and square it, we'll just get a 9. And that's okay to take the logarithm of. So both of those answers are good. For number 12, we want to graph 3 to the negative x plus 2, which is the same as 1/3 to the x plus 2. Sometimes it would be easier to think about it that way. So when we're considering the domain of this function, we want to think what values are we allowed to plug in for x, and we could actually plug in any value that we want. So our domain will be from negative infinity to infinity. We know that our horizontal asymptote will be at y equals 2 because it's always the number in the back. And since whatever we plug in for x will get positive values, we know that our range will go from 2 to infinity. Because no matter what we plug in for x, we'll always get a number bigger than 2. To find the x-intercept, we want to set our function equal to 0. And it doesn't matter which one we do. We can do 3 to the negative x plus 2. And we want to solve for x. So first thing I'm going to do is subtract 2. And then to get x by itself, I want to take log base 3 of both sides. And in this case, we run into a problem because we can't take log base 3 of a negative number, which means that we don't have any x-intercepts. And that kind of makes sense because our range goes from 2 to infinity, so we won't ever cross the x-axis. Our graph will always be above the line y equals 2. To find the y-intercept, we just want to plug 0 in for x. And anything to the 0 power equals 1. So we'll have a y-intercept at 3. So when we graph, we want to put on our horizontal asymptote at 2. And put our y-intercept on at 3. And we can always plug in a couple more points to get some more points on your graph. So if I plug in a 1, I'll get 1/3 to the first power, which is 1/3 plus 2, so 2 and 1/3. And if I plug in a negative 1, I'll get 3 to the first power, which is 3, plus 2, which is 5. So we have a decreasing exponential graph. For 13, we are now graphing a logarithm graph. So for the domain, we want to consider what can we plug in for x. And since we can't take the log of a negative number or 0, the first number we'd be able to plug in is just above negative 4. So our domain will be from negative 4 to infinity. For a logarithm, the range is always negative infinity to infinity. Because when you take a logarithm of something, you can get both negative and positive answers. Our asymptote is whatever makes the parentheses go to 0. So that would be x equals negative 4. And we have a vertical asymptote this time for a logarithm graph. To find the x-intercepts, we want to set our function equal to 0. And solve for x. So 3 equals log base 2 of x plus 4. And then we want to write this as an exponential. So I have 2 to the third equals x plus 4, which is 8 equals x plus 4. So I will have a x-intercept at x equals 4. For the y-intercept, we're going to plug in a 0. So we have log base 2 of 0 plus 4, so 0, minus 3. And log base 2 of 4 is 2. So 2 minus 3 is a negative 1. So we're going to put our vertical asymptote on at negative 4. And our y-intercept at negative 1. And our x-intercept at 4. The next 2 pages are the review pages for the word problems on the Chapter 3 test. For the first problem, we are given the equation for the decibels of sound, and we're given an intensity of 10 to the negative 4, and we want to determine the number of decibels. So we're going to plug 10 to the negative 4 in for I. So B will equal 10 times log base 10. 10 to the negative 4 over 10 to the negative 16. And we can simplify that by subtracting the exponents to 10 times log base 10 of 10 to the 12th. Because negative 4 minus a negative 16 would be 12. And then our log base 10 and our 10 will cancel. So we just have 10 times 12, which will equal 120 decibels. And for number 2, we're given the equation of a pH of a solution, and then we're given the hydrogen ion concentration. So to find the pH, we just need to plug that in. So we have negative log base 10 of 7.61 times 10 to the negative 6. And you can just plug that directly into your graphing calculator, and we will get 5.119 moles per liter. In number 3, we are solving for the amount of days it will take for 120 people to be infected with a flu virus. So we're solving for t, time, and we know the amount of people. So we're going to plug 820 in for y. So we have 820 equals 1,000 divided by 1 plus 990e to the negative 0.7t. And we can take the denominator and the answer and switch them. So we have 1 plus 990e to the negative 0.7t equals 1,000 all over 820. And we want to try to plug the most accurate answer into our calculator so we don't have to keep rounding and we get the most accurate answer. So I'm not going to simplify until the very end. So first thing I'm going to do is subtract 1. So 990e to the negative 0.7t will equal, well, I can cancel out a 0. So we'll say 100 over 82 minus 1. And then I'm going to divide that by 990. So e to the negative 0.7t will equal 100 over 82 minus 1 divided by 990. And then to get rid of e, I'm going to take the natural log. So I have negative 0.7t equals the natural log of 100 over 82 minus 1 all over 990. And now I'm ready to take that and actually plug it into my calculator and get an answer. And then once I have that answer, I want to divide by negative 0.7. So t will equal 12.02. So we can say about 12 days. For number 4, we are investing $5,500 into an account that pays 7.05% interest, and we want to know how much money we'll have in the account after 5 years if interest is compounded quarterly. So for the test, we need to memorize the equation A equals P times 1 plus R over N to the NT, and P is our principal, so we'll plug in 550. R is our interest rate, but in decimals, so instead of 7.05%, we want to change that to 0.0705. And then we want to divide that by 4, because N is the number of times it's compounded per year. And that's going to be raised to the 4 times 5, since 5 is our time. So we can just plug that directly into our calculator. And we'll get 7,842 cents. If our interest is being compounded continuously, we used a different equation, and that is A equals PE to the RT. So we'll plug 5,500 in for P. The E stays. 0.0705 goes in for R, and T is still 5. So if we plug that into our calculator, 7,824 and 41 cents. For number 5, we have an equation to determine the amount of radium that's left after a certain amount of years. So first we want to determine the initial quantity of radium, and that would happen when the time was 0. So we can just plug 0 in for T. So we have that Q equals 76 times 1/2 to the 0 over 1599, which would just be 76 times 1/2 to the 0 power. And anything to the 0 power is 1, so 76 times 1, we'd have 76 grams initially of radium. Determine the quantity present after 1,100 years, so that's what we would plug into T. So Q will equal 76 times 1/2 to the 1100 all over 1599. And you can just plug that directly into your calculator. So that will equal 47.177 grams. And the last part of this question is, suppose 200 grams of the element are now present. How long will it take for 150 grams to remain? So first we want to plug 150 in for the initial amount. So that's where the 76 used to go. And then we have 1/2. We're solving for T. And we want to know how long it will take to reach 200. So we'll plug that in for Q. And then we need to solve for T. So first thing we want to do is divide by 150. So we'll have 4/3 equals 1/2 to the T over 1599. And then to get rid of the 1/2, we want to log base 1/2 both sides. So we have log base 1/2 of 4/3. And that equals T over 1599. So then we want to multiply by 1/5. So 1599 times log base 1/2 of 4/3 will equal T, and we want to plug that into our calculator. 2 ways to plug in log base 1/2 of 4/3. You can do alpha window and scroll down to choice 5, or you can do the log of 4/3 divided by the log of 1/2. Oops, I realized I made a mistake earlier. So the 150 should have been where the 200 goes. Let's fix that. And this should have been the 150. Because we had 200 initially, and 150 will remain. So fix these numbers, So instead of 4/3, it will be really 3/4. And we'll do a 3/4 right here and a 3/4 right here. So that should give us a better answer. So T should equal 663.645. And this is in years. For the last 3 questions, we just need to solve and then use our calculator to get the final answer. So for number 6, the first we want to do is subtract 4. So we have 3 to the 5 minus x equals 16. And then to get rid of the 3, we want to log base 3. So we have 5 minus x equals log base 3 of 16. And then we want to add x to the other side and subtract log base 3, 16. So we have 5 minus log base 3, 16 equals x. And we get x equals 2.476. For number 7, we first want to get rid of the natural log. So we are going to bring the e to the other side. So we have x squared minus 4 equals e squared. And then we want to add 4. And then take the square root. And whenever we take a square root while solving, we want to remember about plus or minus. So in our calculators, we will do e squared plus 4. We'll get x equals plus or minus 3.375. And for number 8, first thing we want to do is add 1. So we have 3e to the x plus 7 equals 9. And then divide by the 3. So e to the x plus 7 equals 3. And to get rid of the e, we want a natural log, both sides. So x plus 7 will equal the natural log of 3. And then we want to subtract 7. So first in our calculators, we want to do the natural log of 3 and close the parentheses and then subtract 7. And we should get x equals negative 5.901.